Hello students, welcome. Previously, lesson 8, form 4, topic 4, we were dealing with the applications of the electrochemical cells or voltaic or galvanic cells. And remember we said the redox reactions in an electrochemical or voltaic or galvanic cells is commercially applied to make the following. Part A, dry cells, which are known as Bremer cells, and a good example, we have picked the Leclerc cell. So, in our previous class, we have done part A, and today, in our lesson 9, we are going to do the wet cells, which are known as the secondary cells, or they are known as accumulators. And a good example of these secondary cells, we are going to pick the lead acid accumulators or the car battery. So tomorrow, inshallah, or our next class, we are going to be dealing with the fuel cells, which we are going to take the hydrogen oxygen cell as the example of the fuel cell. Remember we said each of these cells will be explained in details. So today in this lesson, we are going to see secondary cells, which are known as wet cells or accumulators. We are going to discuss it in details. So you're saying an example of a secondary cell is the lead acid accumulators, or the one that we have in car battery. It looks like this. So next we proceed. We are saying secondary cells are rechargeable, unlike the primary cells or the dry cells. Remember we said once the dry cell is used up, it will be discarded because it cannot be recharged and reused. But secondary cells, they can be recharged and reused. So we're saying lead acid accumulators or these secondary cells are made up of Roman 1 lead plates that forms the negative terminal. And remember, the negative terminal was our anode. Then Roman 2, we're having lead 4 oxide that forms the positive terminal. Remember, the positive terminal was just the cathode. We're saying the two electrodes are dipped into concentrated sulfuric 6 acid. So remember, when we were dealing with primary cell, we said the base, which was a mixture of ammonium chloride and zinc chloride, was acting as the electrolyte. So when we are dealing with these accumulators, we are having concentrated sulfuric acid as our electrolyte. So we're going to proceed, and we're saying at the negative terminal, that's the anode, lead atom loses electron to form lead 2 ions. Remember we said at the negative terminal or at the anode is the electrode where oxidation occurs. And what is oxidation? It is loss of electrons. So we're having lead plate or lead solid losing electron to form lead 2 ions. So electrons lost are written on the product side or on the right hand side of an ionic equation. Next, at the positive terminal, that's the cathode, we are told lead 4 oxide reacts with the hydrogen ions in sulfuric 6 acid to form lead 2 ions. This is the equation at the cathode. We are having lead 4 oxide solid reacting with 4 moles of hydrogen ions from the sulfuric 6 acid, which was acting as our electrolyte plus 2 electrons gained from the anode. So we are going to get lead 2 ions aqueous and also 2 moles of water, which is liquid. So we're saying next, the lead 2 ions formed reacts instantly with sulfate ions from sulfuric 6 acid to form insoluble lead 2 sulfate. Remember, sulfuric acid is written H2SO4. So when it dissociates, it produces hydrogen ion and also sulfate ions. So remember, we are told these hydrogen ions reacted with the lead 4 oxide to form lead 2 ions. So the remaining sulfate ions will react with the lead 2 ions formed to form insoluble lead 2 sulfate. So we're saying the overall cell reaction is called discharging, and we are going to see it here. So the way we are going to write this discharging reaction or the cell reaction, I will be going to explain down here. So we are going to have lead solid plus lead 4 oxide solid plus 4 moles of hydrogen ions aqueous plus 2 moles of sulfate ions aqueous. We are going to get 2 moles of lead 2 sulfate solid plus 2 moles of water, which is liquid. So this cell reaction is reaction for the discharging process. So as the battery discharges, lead and lead 4 oxide are depleted or they are reduced, and the concentration of the sulfuric 6 acid also decreases. So we can know if the battery is discharging or not by just measuring the density of the sulfuric 6 acid, because it will decrease when the battery discharges. So we are saying during recharging of the battery, the electrode reactions are reversed so that to restore its original reactance. So that means we are going to reverse this discharging cell reactions. So we are going to have the recharging cell reactions like this. So when we are recharging, our products during discharging process will be our reactants, and the reactants during the discharging will be our product. So how are we going to end up having this equation for the discharging? So we will explain down here. First of all, we are supposed to know our reactants. So we start with the first reaction, and that reaction was lead solid or less lead plate losing electrons to form lead 2 ions aqueous plus 2 electron lost. Then we are having lead 4 oxide at the cathode solid reacting with 4 moles of hydrogen ions from the sulfuric 6 acid plus the 2 electrons lost from the anode to form the 2 ions which were aqueous plus 2 moles of water. That was the other reaction that we had. Then the third reaction, we said the lead 2 ions formed instantly react with the sulfate ions from sulfuric 6 acid to form insoluble lead 2 sulfate. So this is solid. So we have to add these three equations to form the overall equations for discharging for the cell. Okay, so what we see on the reactant side, if they appear on the product side, we are going to cancel out. So these 2 electrons will go with those 2 electrons there. Then this equation that we have lead 2 ions reacting with sulfate ions giving us lead 2 sulfate, we are going to multiply by 2. All we are going to multiply by 2. Then we are going to start with lead solid. So this is lead solid plus the other reactants, that's lead 4 oxide. This is solid plus 4 of hydrogen ions aqueous plus. So 2 moles of lead 2 ions will go with this lead 2 ions. 1 mole of lead 2 ions, another mole of lead 2 ions. So when you add the 2 on the product side, they will be cancelled out with the 2 lead 2 ions in the reactant side. The reason why we were putting 2 here to multiply the whole equation was on the product side we had 2 moles of lead 2 ions. 2 moles of the 2 ions. So we have to put 2 here so that they disappear with each other. So we are going to say plus 2 moles of sulfate ions. So here we have sulfate ions aqueous. Then arrow, we are going to write our product side. In our product side, we have only 2 things. 2 moles of lead 2 sulfate solid plus 2 moles of water. That's what remains on the product side. So this reaction or this cell reaction is for the reaction for discharging process. So when we reverse, that means we are going to have the recharging cell reaction. Learners, that's the end of our lesson today. In our next class, we are going to discuss the last cell, that is the fuel cells, which we are going to pick the hydrogen oxygen half cell. Thank you for watching.